Well, welcome back to the next episode on the Truvox. I'm sorry it's taken so long for me to get around to this, but there's been a few other projects that have required a bit more attention than I thought, and it's taken me a while to finish those off. Now, I seem to remember at the end of the last episode, I said we were going to button this thing back up and do some testing, which I have done. And there are two remaining problems with this. One of them is potentially a bit more tricky than the other. So we're going to deal with the easy one today. And that is the two resistors that are used to drop the AC for the drive motor and the take-up motor when the thing is in play and record. And during testing, those resistors were getting really hot. I'll put some footage up over the top of this so hopefully you can see that. But they should be dropping about 22 to 23 watts according to how much voltage is dropped over those resistors. And you know, they're up at 140, 150 degrees C, which is clearly not ideal. In fact, it's not safe to let the thing go out like that. Now, as to why they're getting so hot, I don't know. The resistors themselves measure correctly. The only thing I can think of is that the actual substrate that surrounds these resistors is either degraded over time, possibly due to moisture ingress over a long period of time stored in the loft or wherever this thing was stored. But regardless, we are going to need to do something about that and to swap those resistors out. Now, I've done a fair bit of research looking at potential replacements, and everything that I can find is either too big to fit within the chassis or requires some form of active cooling, so fans, fans to put there across a heat sink, for example. So what I have decided to do is to look at ganging some resistors in series in order to give us the close to the original resistor values, but to increase the wattage of the overall resistor package. So I'm going to get this apart again. I'll show you where those resistors are. We'll then take them out and we'll have a look at how we're going to implement these new resistors within the chassis itself. Okay, so here we are again with the chassis split apart. So this is the drive unit, upside down obviously. And the two resistors that we're talking about, there's one over here, and this is the one that drops the AC voltage with a take-up spool. And then there's another one that sits underneath this plate here and drops the voltage for the drive motor here. Now I've removed the drive motor one, so these are what they are. This one in particular is 500 ohms, 20% resistor. I don't know what wattage these are, it's not printed on them, but I imagine that when they were new, probably 25 watts, something like that. And this is what we're going to replace. And we're going to do it by putting a bunch of these wire wound 14 watt resistors in series. These are 2.2 Ks. So 4 of these in series is going to give us somewhere around 525, 30 ohms, which is certainly within the tolerance of the 20% for the 500 watt one here. Now obviously we can't just wire those in because we're talking about high AC voltages here. They need to be isolated from the chassis. So we'll use a piece of phenolic material. This is stuff that I use to repair and make things like valve circuitry. And we can put some little posts in and then wire those into series and then fit them to the chassis. So that's the next order of business, is to cut some phenolic up, make some brackets so that we can fit it to the chassis isolated from the AC voltage that's going to pass through it, wire in those resistors and then fit them, and then we can have a look and see whether or not we've managed to make any difference. Okay, so I'll bring you back when I've manufactured those fittings, and then we'll see how we get on. Right, so I finished making the first resistor pack. As you can see, this is 4 2.2K 14 watt wire round resistors. I have matched them as closely as possible, so they're all pretty similar. And also, I don't know how well this shows up, but all the leads are cut to roughly the same length, just to try and make sure that they are as closely matched as possible, so that we don't get one getting hotter than the other. And these are then mounted on standoffs onto this phenolic material. I've taken some trailing leads just through the back, so I'm not putting leads close to the resistors. And then this is going to get mounted down underneath the chassis here, where the old resistor was. And then wired up, and yeah, hopefully this one here then would be what, 14, 28, 56 watts. So that should be an improvement. So I'm going to fit this one, and then I'll make the next one, which will be 3 22K resistors. So I'll bring it to roughly 740, something like that, ohms. Slightly lower wattage, obviously with only 3, but that doesn't matter because we're not dropping as much power. So the thermal stress should be a bit lower on that one. So we'll get that one done, get both these fitted, and then I'll bring you back and we'll have a look at whether or not we have helped solve the overheating resistor problem. Good. Okay, so we've completed both of those resistor networks now. So we have the one which drives the drive motor, main drive motor, and that is a network of 4 2.2K resistors in parallel. So that's going to drop all that down to about 550 ohms, which is pretty close to what it was. And these are 14 watt resistors, so that's 56 watts of power there. And then the one on this side here, which is the drive, or the reduction network for the drive during play for the fast forward. I'll just reposition the camera around. And so this one is again 4 14 watt resistors, but this time these are 180 ohms, so they are in series. So together that gives pretty close to the 700 ohms that we had on the resistor that has been removed. So with that done, we will put the machine back together again, and we'll run it, and we'll have a look and see how much we've managed to reduce the overheating in those two resistors.